and share. So yesterday we were looking at these things. I was talking about whether you know all these calls, jump, return and that. You said that you do not remember it. What I'll do is today I'll share 2 links with you for all these calls, right? With the example, and 1 video lecture for all the addressing modes. So you go through those 2 things in the weekend, because tomorrow you don't have class, day after tomorrow and on Sunday you have holiday. So you watch the lecture on these 2 days, and by Monday we'll start the new one, pipelining, right? So yeah, so the micro instructions mostly which are there we have already covered. Now how we have covered, I'll show you. We have done accumulator and stack, right? So in stack what we use is push and pop. So these are the micro instructions for that, right? So we already know these. Then for pop there is one more. So this diagram we have already seen in my notes. Then yeah, this is the same one. Then for next one we have for accumulator. So like that we have some micro instructions, this add and all that. These examples also we have seen. So I was telling you that simultaneously we will be covering all the topics, right? Maybe I should open this one, course handle. So that is how we have covered. One sec. Yeah. So this is one address instruction, zero address instruction. We know that what are zero address. That means we do not need address. Why address is not needed? Because whenever we say push A, that means stack will be operating, and stack can do only 2 things. One is push, one is pop. These 2 operations can only be performed on stack. That means the upper cell can only be used, right? So all this we have seen. Then with all the register modes. So for that you should know addressing modes. You'll be doing that on Saturday and Sunday, you'll be revising them. Then you'll easily be able to write these, right? So that is no big deal for you. Then yeah, addressing modes, you'll revise it. I'm just asking you to revise because it is not part of computer organization. Still, if you are not able to understand any addressing mode, I'll let you know, right? I'll also share my notes of addressing modes. Everything is very clearly written. The way I have explained you every other thing, like that there is for addressing mode, right? So all this you'll be doing it. Then there are some branching instructions. So with the flags, so with flags you can watch the video and can complete it, right? So again I come back to my notes. We have seen the fetch cycle. Now we see how the execution cycle takes place. So we resume now, and this is the end of chapter. So come here. This is the one. So instruction cycle. So I have to tell you, I have already completed fetch cycle. Now I have to tell you execution cycle, and then building data path and microprogramming we have completed. So let's see how execution cycle works. See, execution cycle is there finally to execute the command. The command will be executed by the microprocessor or the processor, In the processor, there are some register, or maybe it generates the address in the memory. In that generated data will be coming in the like as data operand in the processor, so that processor can do the processing if it has to add, subtract, or whatever operation it has to go. So operation we provide here, right? So suppose if it is 8 bit, that means 2 raised to the power 3, it is 8. So when it is 8 bit, 3 bits can represent these 8 cells in the memory, right? So that is why operation code we have divided for 3 bit, and rest bits are assigned for address. Now, when we have this opcode, it could be anything like add, subtract, multiply. In address, either it is from register or from address, from accumulator or from the memory. So here we give it to the memory, right? Then what happens? This is your fetch cycle, you already know. CPU or processor will generate the memory request if it has to fetch from the memory. If we have given like M 2000, so it will fetch from the memory. This data will be loaded here, and then the process continues for execution. What it is doing? It is decoding, that means decoding these bits to signal. These signals, so there are many signals like D0, D1, D2 up to D7. Maybe D0 means addition, D1 means subtraction. So like that, I have shared this, I'll again share this, read it with you, that document. And in that it is written that D0 means add, D1 means multiply, and all such things are written, or the meaning of these. But although it is not universal, because it depends on the microprocessor, which processor we are using, and it may change. So you don't have to remember it. It is only convention is provided in that document, you can read it, otherwise it might change. And decoder generally decodes the opcode to the signal so that ALU can understand. ALU is understanding only the signals. And finally, once it is done with the execution part, it will store. Either it will store it in accumulator, or the result is very big, then intermediate results are required. Then accumulator further requires certain register to store the temporary part of it. So it can use temporary register. Still, if it is very calculative thing, then it may break into parts, and it will fetch, or it will take only uh, that particular cell where it is able to process it in one cycle, which is generally known as the clock time or clock cycle of a CPU. That means in one cycle, in one clock time, in one processing time, in one cycle, it is able to go. What is that cycle? Fetch and execution cycle, right? So this is it. Next are your, yes, someone
Could you
asked,
explain one more time now?
uh, uh, this one?
Yes, ma'am.
Yes. So what is happening is, we are looking at the execution sequence. In execution sequence, we have already fetched. So how fetching is done, I'll again repeat it here, right? We have already fetched the instructions. Now these instructions need to be added in the memory part. Where the memory part is there, either it could, we can use the memory of accumulator. Through accumulator the ALU can take. If there are two operands, or maybe if it is very big calculation, we can go with the temporary register. Now when we have to execute it, we require two things. One is data and one is instruction. Instruction is your operation code, which tells either you have to perform, let's go with very basic ones, add, multiply, right? So these are the basic operations. It could be load, store, move, any operation. So for that we are providing operation here or the instruction, and here we are providing address where the data or operand will be fetched or provided to the ALU. Now this address could be from register or it could be from memory. If it is from register, it will be directly fetched or taken to the ALU. If it is from memory, then it is taking 2 cycles that I will explain you how it is taking 2 cycles to be fetched. So this is your entire 8-bit address which is passed to ALU. Now if it is 8-bit, for this address space, we have given 3-bit to opcode and remaining 5-bit to the address space. Now, once we have fetched it, suppose if it is memory, CPU will generate the address of memory that at this particular address, you will find the data. So, first cycle will go to the memory at this particular address, then it will take the data, fetch it to instruction register. Instruction register is nothing but it just takes or holds the instruction, that what is the next instruction to be executed. That means there is opcode and there is address or maybe anything, let's say data, on which the execution need to be done. Now this entire thing will go to the decoder. What decoder will do? See, we can understand or we can code, we can give, like we use Java. So in Java we use user friendly or English languages. Like for example, if you are using, if you are taking, let's say you wish to print. So you are writing system.out.println. So this print means you have to print it on the screen, right? It means you can use this user friendly language, but machine cannot understand. So what we are doing is, for machine to make understand, we are just sending it the binary language. So this is up to here, it is the binary language, which means in 0 and 1. Whereas ALU is your arithmetic logic unit which works on signal. Why it works on signal? Because see, it can take 0 and 1 but it doesn't know what does that mean. So 0 means high, low, 1 means high. It will take these signals and perform the operation. So that's what your decoder is doing. It is just decoding these bits as high and low and explaining it to ALU. That is why we have used decoder. Now, why we have taken this 3 here? Because see, we have 8 bits. So through 8-bit you can easily, if you take 3-bit address space, you can easily cover all the address space, right? So what you're doing is 3 means or 8 means D0 to D7 you are going. It means 8 cells or 8 operations that could be given to the ALU. So D0 means add, let's say. D1 means multiply. D2 means some other operation, like that you can pass. So suppose you are passing add. Add means D0. That means we have passed D0. Whenever D0 pin is enabled or whenever through D0 pin we are passing a signal, it means we wish to add to ALU. So now ALU will add it, right? And if any external flag or external condition is there that store this or add if carry or interrupt is generated or any other flag operation is given, it has to do accordingly, right? And this can be stored if any external operation is required. Let's say if you add if carry, so you can add and give the carry to external storage or whatever is required. So this storage space is required. An accumulator can give the input, and because it is the default storage, that is why it is used. What is your PC? PC is your program counter. Once the PC program counter has given that this is the program that need to be executed, this is the program that need to be executed, it will increase its step size. Once the program counter has given this for execution, it will increase its step size, go to the next phase. That means it will go to the next program that need to be executed, right? How the step size is increased? If it is contiguous memory, maybe the next one. If it is branching or maybe any other call or function call is there, it will increase the step size, or maybe it will go to that particular step where it need to go, right? So it is storing it there. Yeah. So any doubt in it?
No, ma'am, I think I understood better.
Okay. Next, so yeah, so these are the ones like D0 you have plus sign, D1 multiply, D2 division, likewise D7 XOR. So some meaning is binded with it, right? For these opcodes, that's what I was telling. Someone asked me once that why register we can directly fetch from register, but whereas memory takes two operations or two cycles. So here is the diagrammatically it is explaining when you have instruction register. So instruction register is holding the address of the next instruction. Now if it is register, so directly R0, R1 or R2 register name could be given, and ALU knows these registers and it will directly fetch the data. Suppose if we give R1, so here there may be binary sequence of data which is present, ALU will directly take this sequence. Yeah. Whereas if it is memory address, then what need to be done is instruction register will give the address. Now if it is found that it is a memory address, right? So it is not present at ALU, at arithmetic logic unit. It is not present there. It is present outside this memory, right? So first what CPU or ALU need to do is, it need to generate the memory address. So it is generating this memory address, right? And it will go to the memory and then it will be fetched to ALU. That is why it is taking certain 2 cycles, whereas the register of uh, of any processor are present in ALU itself. So it is a 1 cycle process, right? Yeah. So any doubt in it?
So if I can just confirm this, in register cycle, the register is already part of the ALU. The
Mhm.
it directly accesses the register and it'll be done in 1 cycle. But in memory, the memory has to be first transferred to a register, and then the thing will take the information from the register and do it. Right? That's
Yes,
basically it
yes,
now.
yes. If you wish to directly take it like this command is valid, move R0, no, let's say add R0, comma, and you give the memory address, right? So this command is possible. I'll show you. I have shown you the list of commands. Yeah. See, this command is valid, add R0 and this one, right? Why is it valid? Because see, first it is generating the request that data need to be fetched. So in 1 cycle, it will fetch that data. Then what it will do, whatever data is there at R0, it will add that data with the contents of R0 and it will store it in R0 itself. So R0 will now have the data which was present at R0 plus the data which was present at this location, right? This is valid Someone asked me that why this is invalid. It is invalid because first of all, what has to be done? R0 it can directly fetch, no problem. At 2000, what it has to do is, first of all, it has to take the address. So one memory request to fetch the details, right? Either it is storing it in temporary register or accumulator by default. Then what will happen is, once it is adding it to this R0, the contents of R0 and contents of at this memory location, then what it has to do, it has to store back to this memory again, right? Because it cannot take it for let's say if this is the memory location, so it is not at ALU, so it need to regenerate the address and then store it to memory location. When it is doing it all this, the processor is busy with this, because if it is busy with any register, either temporary register could be used or any other, but we are not explicitly storing it somewhere. If we store it, let's say we say that store, first of all move it to R0, then add, and then store it at this memory location. Again we use the word instruction store, then it is possible. See, the instruction is possible, but not exactly in same this thing at same format, right? Yeah. So any doubt till here?
No, ma'am.
No, ma'am.
12:30. Okay. So now, so that's all. Now I'll share these notes with you. The ones with this one and yeah, these addressing modes. Actually, what all addressing modes are required, I'll tell you this. These are the addressing modes which are required, right? So you can learn them. These are all these addressing modes, and I've written everything here. Yeah, so you take one time, you go through them, and you'll be able to recall what are all these, and whatever is required in these addressing modes, right? Set, carry, and all these situations, those are also described here itself, right? So once you go through them, you can easily able to understand, right? So I'll share them, and by Monday I expect that you are thorough with all addressing modes. You know all the instructions, set, carry, zero, what happens, and all the instructions. Go through all the video lectures that I have maybe discussed, or you can watch any other video lectures if you feel that particular topic you are not clear with. And also go through the book Hemature. You can download it online, and if you are not able to download it, then let me know. I have the book with me. I can scan and share the pages. So few pages I can do that. Otherwise, if some students are there in the campus, they can go to the library, just scan that book and share in the group. This can also be done. But do make a habit of reading from book, and if you do not understand anything, let me know. Yeah, so from Monday we'll start with pipelining. Yeah, very important topic. If you are going for any gate exam or ISRO or any technical exam, then at least 5% of that exam will consist of this. So 5% is a great one, right? So at least 6 marks gate questions every time it comes from pipelining, right? So we'll cover that.
Ma'am, from when will you be taking classes, like in the class?
In the class, so I need to confirm this from you. How many students are there in the campus? Maybe you all can unmute your mic and you can reply me.